Today I will teach about conformal mapping. Conformal mapping is one of the important topic in complex analysis. In this section, the geometric consequence of existence of derivatives of complex function. The conformal mapping explains the geometric consequence of the existence of derivative of complex functions. So here, what I will explain what is conformal mapping, definition, and how to check a function is conformal mapping, and next some examples. So before the definition of conformal mapping, I will give the definition of curve. What is the curve of a complex plane? What is a curve of a complex plane? A curve C in the complex plane is a function gamma from AB to C. That means the curve C determined by the two real valued function x of t and y of t. So we have a line AB to interval, not an line, interval A to B. This from C, complex plane C, to some x of t and y of t. So t from x of t is a function and y of t also function. So x of t plus iy of t is a complex function. So each t is an element of AB. We can find corresponding to T naught. T naught is an element of AB. X of T naught plus Iy of T naught is an element of C. So these points, the collection of these points is a curve. Okay. The starting point of a curve is called, one more explain, AB. So gamma in the complex plane. So each of the point, some T naught, we have a complex number. Another T1, we have a complex number. Each of the point in AB, interval AB, we can find the points in C. So we can join these points. We got a curve. That is gamma A to gamma B. This is called curve. The starting point of a curve is called initial point and ending point is called terminus. Terminus of curve. Okay. Next, simple curve. What is the meaning of simple curve? The curve C is said to be symbol gamma T1 not equal to gamma T2 if T1 not equal to T2. So any two distinct numbers, we got two distinct points in C. Such curve is called simple curve. So I will give some curves. This is a curve. This is a curve. This is another curve. This is another curve. This is another curve. So these are the curves. One more curve I will give. This curve. So this is a simple curve. This is also a simple curve. Simple curve. So any distinct point, it has a distinct images. So these are intersected. This point is an intersection. This is an intersection. This is an intersection. This is an. So this is not simple curve. This is a simple curve. This is simple. This also have an intersection. So this is simple curve. This also have an intersection. In the case of simple curve, we can say no crossing is possible. Such like this crossing. No crossing is possible. So, in the case of simple curve, no crossing is possible. So, such curve is called simple curve. And initial point and ending point are same. Such curve is called closed curve. Okay. So, set of A and set of B. A, B are interval defined as C, gamma A to gamma B. This gamma A and gamma B are equal, then called such curve is called simple curve. Okay. Next we can see what is conformal mapping. Conformal mapping. Let f be a continuous function. F be continuous function defined on D. And Z0 is an element of D. C1, C2 be two regular curves passing through Z0 laying in D. C1 dash, C2 dash be the images of C1 and C2 C1 dash C2 dash be image of C1 and C2. Then angle between C1 and C2 is same as angle between its images C1 dash and C2 dash. I will explain once more. F be a function defined on D, continuous function defined on D. Z naught is an element of D. C1, C2b regular curves passing through Z naught. C1 dash and C2 dash b images of C1 and C2 if angle between C1 and C2 is same as angle between C1 dash and C2 dash angle. Then we can say then F is said to be conformal mapping. So I will explain geometrically. Let we have a C plane. In the C plane, we have C1, we take a Z naught. C1 and C2 be two curves. So angle between C1 and angle between C2 you can find so we take a Z naught, we take a curve C1, C2 and angle between C2 and angle between C1 we take in between C1 and C2 angle between C1 we take theta 2 and this angle is theta 1. So bigger angle is theta 2 and smaller angle is theta 1. So in between angle is bigger minus smaller. So theta 2 minus theta 1. The images. Next we consider the images. So we have f of z naught. We have two curves C1 dash, C2 dash. C1 dash is image of C1 and C2 dash is image of C2. Then you consider the angle between C1 dash and C2 dash. This also theta 1, theta 2 minus theta 1. If this images angle between the images of a curve is same as angle between the C1 and C2, then we can say F is conformal mapping. Okay. So this is the geometrical explanation of conformal mapping. So in the definition, we will give the C1 is regular, two regular curves. C1 is two regular curves. What is the meaning of regular? Regular curve means C is a curve that C is C be a curve. C is differentiable. A curve C is differentiable if Z dash T exists and continuous for all T. Then only we can say C is differentiable. So, in the case of derivative of C, of each and every points, these derivatives are not equal to 0. Then we can say C is regular curve. Once more, I will explain. C is a regular curve. So we have AB. So its images is C. Images is a curve. Is gamma A to gamma B. Be a curve. So for all T, so many T's are there. So in the case of all domain points corresponding to set of T we can find. So each of the set of T, its derivatives are exist and continuous. Then we will say C is differentiable. Okay, each and every point of C, each and every point of AB corresponding to C is differentiable. Then we can say C is differentiable. So these derivatives are non-zero. Z dash T not equal to 0 for all T element of AB. Then we can say the corresponding curve is regular. So in the case of definition of conformal, C1 and C2 are regular. C1 and C2 are differentiable and its derivatives are non-zero. See, corresponding C1 images are C1 dash and C2 dash. The angle between C1, C2 and angle between C1 dash and C2 dash is same with respect to F. Then we can say F is conformal mapping. Okay. So if you need to check F is conformal, so you need to take two curves, then its angle, you find out the angle, then you can find the images of C1 and C2 and then you can find the images angle, images curves angle. These are equal, then you can say the curve is conformal. But this is very difficult. So we have a theorem for easy to check the function is conformal or not. So I will state the theorem. Let f be an analytic function defined on D. F be analytic function defined on D. Let Z0 is an element of D if f dash Z0 not equal to 0, then f is conformal. Okay, this is a theorem. Okay, so f is analytic in a domain D. Then you can take arbitrary point in D. F is conformal at Z0 if f dash Z0 not equal to 0. Okay, so we can see some examples. You take f of z equal to 1 by z. And find the points where the mapping F is conformal. Okay, so we have a theorem f of z naught, f of z is conformal at z naught if its derivative of at z naught is not equal to 0. So here you have f of z equal to 1 by z. Okay, f of z equal to 1 by z. So first of all, you find its derivative, f dash z is minus 1 by z square. So f of z equal to 1 by z is a function when z not equal to 0. So f of z is defined for all c except at z not equal to 0. And f is analytic for all z except at z equal to 0. So z not equal to 0, f dash z is not equal to 0 for all z except minus except 0. So we can say f of z is f of z equal to 1 by z 1 by z is conformal since f dash z equal to minus 1 by z square not equal to 0 for all z minus 0. Okay. Next, one more example I will explain. W equal to z power n is conformal. Find the points. This function is conformal. Which points? This function is conformal about z naught. So what are the z naughts? We need to find. So in the theorem, we know that f dash z naught not equal to 0, that z naughts are conformal. That z naught are conformal points with respect to f. Conformal points with respect to f. Okay. So we need to find corresponding derivatives. So f dash z equal to n z power n minus 1. So n z power n minus 1 not equal to 0 for all z minus 0. So we can say this function is conformal for all points except the origin. Okay. So we can say f dash z f of z is conformal for all z except 0. Okay.